Good afternoon. Today we're going to be talking about the environmental impacts of the Chernobyl disaster by Pavel, Petrov, and Bowen, Walton. On April 26, 1986, at 1:27 a.m., a major disaster occurred in the Soviet Union near the town of Pripyat, about 20 kilometers from Chernobyl. An experiment at the Chernobyl nuclear power plant went wrong, causing an explosion at reactor 4. The explosion was followed by several more, releasing huge amount of radioactive material into the air. It's estimated that about 50 million curies of radiation were released, which scientists compared to 500 times the power of the atomic bomb dropped on Hiroshima. This release of radiation caused serious harm to the environment and people living nearby, leading to lasting health problems and contamination. The Chernobyl disaster remains one of the worst nuclear accidents in history, showing the dangers of nuclear energy when safety measures fail.
The huge release of radioactive material from Chernobyl disaster had a widespread health and environmental effects around the world, which required careful planning and international cooperation to address. Many dangerous radioactive elements or isotopes were released during the accident, and some are still present in the area today. These elements can cause serious health problems, including cancer, leukemia, damaged internal organs, and in some cases lead to death.
The explosion in Chernobyl killed 2 workers and injured 2 others, while 28 firemen tragically died from radiation exposure within 2 months. Evacuation efforts began 36 hours after the disaster, but by then many people had already been exposed to high radiation levels. On the second day, 50,000 residents of Pripyat were evacuated, and in the weeks that followed, the number 150,000 people that were displaced from the surrounding areas. Radioactive isotopes spread north and northwest, affecting the area of 150,000 square kilometers across the Soviet Union. By the third day, radiation was detected in a number of parts of Europe, particularly in Sweden. As the world searched for the source of radiation, Soviet Union finally confirmed the accident. Radiation levels increased globally but soon returned to normal levels, according to the International Atomic Energy Agency.
The Chernobyl disaster caused significant radiation contamination in both soil and water, resulting in the establishment of a 30-kilometer exclusion zone around the site, which remains largely uninhabited. Although the area is restricted, some former residents have returned to their homes. Currently, more than 180 small communities are located within the exclusion zone, but many children are prohibited from living there. The underground water sources within the exclusion zone were severely impacted with radiation, with strontium 90 being one of the most dangerous isotopes affecting the water. Researchers discovered radiation contamination even in deep groundwater reserves.
Radioactive elements were detected in rivers across various countries, including Russia, Austria, Finland, Sweden, and other nations in Central and Northern Europe. The contamination of soil and water around the disaster site was not uniform. Due to shifting weather patterns and wind, the radioactive cloud spread in the curved trajectory, causing the heaviest contamination in certain rivers and soils in European countries.
The Chernobyl disaster had a profound effect on plant life, both immediately and long term. Plant growth in both positive and negative ways. In immediate aftermath, vegetation near the reactor site was exposed to high levels of radiation, leading to severe damage. The red forest, the area closest to the disaster, saw trees and crops wither, turn brown, and die from the radiation. Additionally, radiation suppressed plant reproduction, limiting the ability of many plant species to regenerate and grow.
The radiation exposed from the explosion led to mutations in the DNA of vegetation in the area, causing abnormal growth and developmental issues. Most plants experienced reduced growth rates or failed to grow altogether due to the contaminant soil and direct radiation. Additionally, long-lived radionuclides like cesium-134 and strontium-90 bind to soil particles, particularly clay and organic matter, rendering the soil toxic and severely limiting the ability to support healthy plant life.
The Chernobyl disaster had a major impact on local wildlife, causing a sharp decline in species like the gray wolf, Eurasian elk, barn swallows, and some frogs, such as the eastern tree frog. Animals living close to the explosion were especially affected by the radiation, leading to various problems. Many suffered from genetic mutations, deformities, and developmental issues, which caused many to die or struggle to survive. The radiation from the explosion changed the animal's DNA, leading to physical and developmental problems that contributed to their population decline.
The Chernobyl exclusion zone is a 30-kilometer area around the Chernobyl nuclear power plant, established after the 1986 disaster due to high radiation levels. The zone includes the abandoned city of Pripyat near towns and all the evacuation after the explosion. Most of the area remains off limits with high radiation levels, making the permanent habitation unsafe. However, wildlife has flourished as the absence of human activity, with species like wolves, lynx, and wild boar thriving. Some parts of the zone with lower radiation are used to control tourism, scientific research, and renewable energy projects. The zone serves as both a reminder of the disaster's impact and the site of the ecological recovery and research.
In the absence of human activity, wildlife in the Chernobyl exclusion zone has flourished, with species such as wolves, lynx, bison, wild boar, and even endangered animals like the Przewalski's horse establishing stable populations. This resurgence highlights nature's resilience in the face of adversity. Additionally, some species have developed unique adaptations to survive the radioactive environment. Certain microorganisms, such as the radiotrophonic fungi, can convert radiation into energy, allowing them to thrive where other organisms might struggle. Likewise, some bird species have found physical ways to cope with radiation, with some even showing improved health in these contaminated areas. These phenomena underscore the remarkable adap- adapt- adaptability of life, even in environments profoundly altered by radiation.
The Chernobyl disaster sparked important inactivities to improve nuclear safety, leading to the better training for nuclear operators and others involved in the plant management. These efforts have contributed to long-term strategies for managing nuclear facilities and have helped scientists predict the environmental consequences of the future nuclear accidents. In addition to safety improvements, there have been community restoration efforts in regions with lower radiation levels. While many areas around Chernobyl remain uninhabited, programs encouraging human activity such as tourism, scientific research centers, and renewable energy projects are helping to revitalize parts of the area and promote sustainable development.
The Chernobyl disaster is widely regarded the nuclear as the nuclear accident with the most costly consequences, with estimates of total exceeding 700 million to assesses the severity of such events. The International Atomic Energy Agency developed the International Nuclear Event Scale, which ranks nuclear incidents based on their impact. The Chernobyl disaster is ranked the worst nuclear accident in history, receiving a level 7 rating on the INES, the highest level of severity.
Chernobyl is one of the two only events rated as level 7 on the International Nuclear Event Scale, with the other being on the Fukushima nuclear disaster in 2011. While Fukushima was a major nuclear accident, Chernobyl still stands out because of the massive release of radiation, its environmental damage, and their long-term effects. The impact of Chernobyl is still felt today, with large areas around the plant remaining uninhabited and lasting challenges in nuclear policies worldwide. The Chernobyl disaster on April 26, 1986, released large amounts of radioactive material like iodine-131, cesium-137, and strontium-90 into the atmosphere, causing widespread contamination.
Over 100,000 people were evacuated from nearby towns due to the dangerous radiation.
The environmental damage was severe, with radiation harming plants, animals, soil, and water.
Surprisingly, over time, the wildlife, including wolves, wolves and deer, have thrived in the Chernobyl exclusion zone despite the radiation.
However, the long term effects are still felt, with some species experiencing mutations and ongoing problems in the ecosystem.
While nature is slowly returning to parts of the area, contamination remains a serious issue, making Chernobyl a clear reminder of the lasting impact of nuclear incidents on the environment.
This is a list of our sources used, and thank you to everyone for listening to our presentation.